Hi guys. Sorry. Today lecture is 14. We almost done about the electromagnetism. So today is really important, guys. We will learn about Faraday's law and Lenz's law. You know, we will learn when you finish this electromagnetism lecture, we start a circuit. Okay, so circuits, you know, it's made by RLC. So if you understand the Lenz's law, you can understand the L induction. Okay, it's really important. Let's look at it. So as you guys know, Faraday's law. So this is you know, description. What is that Faraday's law? Okay. I'll explain easily, okay? So if you wanna guys see what is that Faraday's, you know, laws explanation, you guys can read it. So let's see it here. So you can see here's a magnet, right? There's now current is, you know, flowing to the coil, and look at that. This is a magnet, and okay, this is a coil, okay? I will say, you know. So if the magnet is moving to the inside of the coil or near outside, it doesn't matter, okay? Just for example, this time is inside of coil. You can see EMF is you know, induced. So which means here you can see what's it? Voltage meter, yeah. So you could, you know, so you can see it. At first time there was 0, but now you can check it, the voltages. You know what I mean? So, and the second part is when the, you know, there's a speed, right? The magnet's like this speed or this speed, you know. So if the rapidly to the left, to the right movement, so, you know, where is it? So the more greater EMF is induced, you can see here, right? The arrow here and here. So let's see more about cars. So simply, you guys, I said EMF is induced, right? So EMF is induced electromotive force. Simply thinking, induced voltage, okay? So look at that. Here's coil, right? So as I said earlier, coil is, you know, actually it's a kind of it has an outline here, right? This time is a circle, you know, shape. So, but as I said, the important part is here. Coil, it feels like here, inside of this part, the area, you know what I mean? The space here. If the coils think the fluxes, you know, the phi, the magnetic field is coming to here, if we feel like time goes by, change it, it make induced voltage. What I mean is EMF, induced electromotive force. Look at that. So which means yeah, here, E, right? So E is induced when the time goes by, if the flux magnetic field changes, EMF is induced. And as I said, if we, you know, if I move faster, the more greater EMF is induced. That's it, the Faraday's law. But here's, you know, a thing. Faraday wanted to explain why it happened, but I don't know what exactly happened. But after then, the lenz explained why it happened. That's why I will explain more about Lenz's law. This is the same. Lenz explain with the inertia. Here, so we say we add it from here. This is Lenz's law. If we delete this minus, this is Faraday's law. You guys know inertia, right? Inertia means you wanna keep it, this situation. We don't wanna change it. In coil case, we say they don't wanna change the magnetic field. Look at that. So what I mean is, okay, here, magnetic field is changing, right? But because of the inertia, look at that. The magnetic, the coil itself don't want to change. So they, make it totally reverse way to remove it. You know what I mean? To delete this magnet totally, I will say 180 degrees differences. So totally, if for example, if this is okay, this is the coil, this is plugs, right? Now it's coming here, right? Oh, the coil itself, I don't wanna change it, so coil make it this way. Got it? So, which means, since it make it also plugs, it also make it E. That's why he explained with inertia concept. This is really important. Okay. Yeah, that is the most important part, Lenz's law and yeah, Faraday's law. Oh, look at that. For example, one more here. Here's time. Here's current. Look at that. I forget it. Sorry, guys. So you think, okay, the result is for this. Okay. So from here, no change. I explained the flux, right? Magnetic field, right? So if you didn't understand what I'm saying now it could be equal to pi flux. You guys need to, watch it, the previous lectures, okay? Don't skip it, the lecture. You guys cannot understand if you guys skip it, okay? So here, look at that. I is changing, right? Time goes by. So here's EMF is induced this part. Here's I is no change, which means flux magnetic field is no change. So which means no EMF. Yeah, that's it, guys. Oh, and look at that. Okay, let's see. So, and here's coil, right? As I said, this inside of space, the area is important, right? So here, if you guys can see, no, even I can see. So magnetic field is coming in, right? So Lenz's law, because of inertia, it delete this, right? It's coming up, so that which means I said if the flux is magnetic field is exists, which means current also exists, right? So as we know Ohm's law, right? Here's a Cooper, right? There's some resistance Cooper itself, right? So if the flux is magnetic field exists, which means current also exists, right? And that's why E is induced EMF. Yeah, that's it. Yeah. If you guys, confused about this lecture, let me know, okay? I'll explain more about it. Actually, you can, if you guys wanna know exact example, you guys just search it on the YouTube, Faraday's laws or Lenz's laws examples. Yeah, to make you guys easily, understand, to help you guys. Yeah, I explained Lenz's law. The important thing is this inertia. He explained. Okay, because when you guys learn about later L inductor, this concept is really important. Okay, that's why I'm constantly, emphasizes about it. That's it today's lecture. Have a good night, guys.